Hello students, welcome to class 11 physics class. Today we start a new chapter from your second part, that is thermodynamics. For this year, in this chapter, heat engine and the refrigerator, that portion is not there. So let's start with our first topic of this chapter, thermodynamics. Thermodynamics in first part we studied the kinematics, mechanics portions, okay, law vector portion, that is a different branch of a physics. This thermodynamics also a different kind of branch, the branch in physics where we discuss about the heat and temperature, where we use the three variables pressure, volume and temperature, and we get a relationship between them, PV and T. That branch of physics is called thermodynamics. So, the branch of physics which deals with the relationship between heat and the other form of energies is called thermodynamics. So, mainly in thermodynamics, we discuss about the heat and temperature, and in this chapter, whatever the equation or relationship we get, all that relationship is linked with the three variables, that is pressure, volume and temperature. These three are the three variables of thermodynamics. So before we discuss the main topic or the important topic of this chapter, first we discuss some important terms related to thermodynamics, which term we use in later. First is the system. It is a very important term in thermodynamics, system, which contain the gas or gaseous molecules. So what is system? System, it is a part of the universe in which observations are carried out. Anywhere we can consider it is a system, and whatever the inside it or what we observe it, that is a system. Surrounding, except the system, the other surrounding other parts of the universe other than the system part is called surrounding. Boundary, it is a wall separated the system from the surrounding. It is called boundary, or boundary separate system and surroundings. Thermodynamic equilibrium and thermal equilibrium. Thermodynamic equilibrium means a system is said to be a thermal equilibrium. Any system, whatever you consider, this is a system and it is in a thermodynamic equilibrium. What is its meaning? Its meaning that the microscopic properties do not undergo any change with time is called thermodynamic equilibrium. With time, its property or its macroscopic properties inside that system will not change as the time is increase or decrease. Time is not decrease, we know that time always expand as the time is change, but this properties does not change. Okay, that is called thermodynamic equilibrium. Thermal equilibrium is the system is said to be thermal equilibrium when there is a no flow of heat from one portion of the system to the another, or from system to the surroundings. Then the system is said to be thermal equilibrium. That means temperature remains same or temperature is constant. That is called thermal equilibrium. Understand? I hope understand. System, surrounding, boundary, thermodynamic equilibrium and thermal equilibrium. You in chemistry you also studied the thermodynamics. You have, but this term also be used in chemistry, but little bit different. Whatever you studied here, the later that the first law, zeroth law, you also studied in chemistry, but whatever the sign convention we used in physics, that is opposite in chemistry. That means if we consider it will be positive in work done or the heat, it is positive, but in chemistry that will be negative. We discuss it later. Next, the thermodynamic has two properties. One is a intensive property, another one is a extensive property. Intensive property, properties of the system which depends only on the nature of matter but not on the quantity of matter are called intensive property. That means pressure, temperature, specific heat, etc. These are the intensive property. They depends only on the nature of the matter, not the quantity of the matter. Quantity and nature of the matter both are different things. Nature, what type of matter is there, depends on this, but not the quantity, how much amount of matter is there. But the extensive property, properties which are dependent on the quantity of matter, how much amount of matter is present, that is called extensive property. Example is internal energy. Internal energy mainly the molecular energy, molecular kinetic energy and potential energy. That means it possessed by the gas molecules. As the gas molecule increases, that means the quantity of matter increases, it will also increases. That means this depends on it. Understand? That's why internal energy, volume, these are the extensive property, but pressure, temperature, specific heat, these are the intensive property. It depends on the nature of the matter, what kind of matter we use. Okay. Next, there are various type of thermodynamic processes. First is isothermal process. We discuss it details later, and we also find out the expression of work done in isothermal process and adiabatic process. Other processes not included in your syllabus, but still you have an idea about these processes. So isothermal process means temperature is constant. In which thermodynamic process the temperature is constant, that is called isothermal. That's why it is named isothermal. Thermal means temperature. Temperature is constant. Second is isochronic process. Chronic means volume. Volume is constant. In this process, volume is constant. Del V equals to 0. Isobaric, pressure is constant. Isobaric means pressure is constant. Adiabatic process means in this process, no heat exchange between the system and the surrounding. No heat can flow from system to surrounding and surrounding to system. That is called adiabatic process. Delta Q equals to 0. No flow of heat. Heat also be denoted by Q, delta Q. Okay, these four are the main process. Another process, cyclic process, it process which it return back to its original state after undergoing a series of changes. That is called cyclic process. Non-cyclic process, it is not does not return back its initial state or the original state. Reversible process, reversible, same thing. It will reverse back. Irreversible, which is not reversed back its original state. So many processes are there. Main four: isothermal, isochronic, isobaric, and adiabatic. These four are the main thermodynamic process. Later we discuss in details the isothermal process and the adiabatic process, the work done expression in isothermal as well as the adiabatic process. And when we discuss the adiabatic process, we get the relationship between P, V, and T, because no heat is exchanged in between the system and the surrounding. That's why we get three relationship between P, V, and T. One is a P and V when T is constant, one is a V and T when P is constant, and another one is P and T when V is constant. Clear? Okay. Now the main topic or the first topic of this chapter, that is zeroth law of thermodynamics. Zeroth law of thermodynamics, that is, this law refers if the two systems are in a thermal equilibrium. Suppose you have two systems A and B. It is in a thermal equilibrium with a third system. Then they are also in thermal equilibrium with each other. Temperature is used here to know the system is in thermal equilibrium or not. That means I will explain it. Here in this figure you see that three systems A, B, and C. A and B are separated by a adiabatic wall, and AB is separated by a diathermic wall from C. Okay, diathermic equivalent means heat can flow between the two systems. Adiabatic means no exchange of heat. So in between A and B, no heat is exchanged. But in between A and B and C, the heat will flow. Okay, from A to C and from B to C. So Zeroth law states that if the two systems are in a thermal equilibrium with a third, that means if A and C and B and C are in thermal equilibrium, then A and B also be in a thermal equilibrium. If with C, with the third system, that is C, with C, if A and B both are in thermal equilibrium, then A and B also be in a thermal equilibrium. That is a zeroth law, and it can be measured by temperature. We use the temperature for measure for to know the system it is in equilibrium, thermal equilibrium or not. That means if temperature is constant in 3, that means we can say that all 3 are in a thermal equilibrium. So zeroth law of thermodynamics implies that temperature is a physical quantity which has same value for all systems which are in thermal equilibrium with each other. That means in case of A, B and C, A, B and C's temperature will be same value. If it will be same, then only we say that all three systems are in a thermal equilibrium. So temperature of a system determines whether it is in a thermal equilibrium or not with the another system. Okay. So we can define temperature from the zeroth law of thermodynamics, that it is a scalar quantity. It is called a temperature which is a property of all thermodynamic systems, such that temperature equality is a necessary and sufficient condition for thermal equilibrium. Okay, this is the concept of zeroth law. Next is sign convention. What sign convention we used when we derive some equation or when we do some work? Okay, do some solve some numerical. These are the sign convention, but here it will be here it is a difference from physics, chemistry. So the sign convention is heat is absorbed by the system is positive, heat given out by a system is negative. Work done by system is positive, work done on a system is negative. But in case of a chemistry, all are opposite. The increase in internal energy of a system is positive, the decrease in internal energy of a system is negative. Clear? In chemistry, just all these things are opposite. Heat absorbed by a system is positive, but in case of a chemistry it will be negative. Okay, just these things are different from physics and chemistry. So in next class we discuss about the first law of thermodynamics. So if you have any confusion, please write in a comment box. Thank you very much.